We had a request to do Fall 21 Test 4 that wasn't done this morning. Pretty vague request, but I'll honor it. I remember I said question 1 had issues and I didn't like it as it was on test 4. Well, I want you to treat this as the new question 1 and use it as the study guide. It's very related to the one that I told you not to use, but this is more like yours will be. For this first reaction, what kind of reaction is that? You're making a pi bond where you didn't have one before. What kind of reaction makes a new pi bond? No. We haven't learned that elimination reactions make new pi bonds? You're going to be embarrassed when you see me making that statement emphatically at least 2 or 3 times on previous videos this semester. Okay? So when you realize it's an elimination reaction, you better put some Greek letters in your mind. You don't have to write them on the page. The alpha position is the one with the leaving group. The base removes an H from the beta position. If you take it from any other position, the mechanism won't work. So find the beta position. It's one away from the carbon with the leaving group. Put an H on there. There's 2 H's on there if you're curious. Grab H, make pi, collapse in to make the pi, and leaving group does what leaving group does. Leaves, this mechanism's done. Okay, that first reaction is done. There are no intermediates in an E2. Strong base. Strong, bulky base doesn't even require heat for E2. Find 3 other strong, bulky E2 bases in this morning's notes. Okay? And you'll see if you watch those videos and say, oh, when you see this base, it means E2, regardless of heat. So you want to watch that. Okay. Now we're doing a review reaction for allylic chlorination. This was our last test, and we liked it then. We should like it now. We're going to do it like this. You don't have to redraw molecules. The initiation step involves the breaking of the halogen in half with hooks. Those are hooks. Those are radicals. Prop 1, that radical takes an H from the allylic position. Like this. They hook up there and dumps the rest of the electrons there, and you get HCl. Not too important to show HCl. You can. Very important to show this species here. Right there. And prop 2, what reacts with the radical to make the allylic chloride? Cl. That's a termination step. You would lose a point. Radicals reacting with radicals are not propagation steps. Those are termination steps. I don't want them. No. You have forgotten that in the initiation step, only 1 or 2 molecules of chlorine reacted. The rest of the chlorine is still present, and that's where you get ClCl to react, and it makes this chlorine radical for prop 1. And there's prop 2. that bond pops in half. Half of it makes a bond to the carbon radical. Half of it becomes Cl dot. You can show it like this if you want. I don't really need to see side things, but there it is. That's going to do prop 1. And cycle begins. And you've done allylic halogenation. Nice job. There is no potassium here because it's a spectator. That's a strong nu. Reminder, strong nu. Let's use purple for analysis. Polar aprotic. They're both saying SN2, right? Show me your SN2 knowledge. How does the mechanism work for an SN2? It's one arrow shorter than the E2 that we did earlier. There's E2, 3 arrows. SN2, 2 arrows. Backside attack, leaving group leaves, end of story. That's it. So these are not long mechanisms, are they? They're like a mishmash. It's trying to show you the related nature of everything we've done so far. I hope it's succeeding. Maybe not. What's KH going to do to this thing here? KH has got H minus in it, a strong base. What's the most acidic proton? Give me a number, please. There are only 3 numbers in the molecule. There's a 50 out here. There's a 45 over here. And there's something else down here. What's the something else? Because that's the lowest number. 25. Terminal alkyne. Guys, we got to brush up on pK. Final exam. I think at least 5 multiple choices require knowledge of pKa. Yeah. Let's not talk about the final. It'll get us distracted. Focus on this. Terminal alkyne pKa 25. You're going to have to show the H. You're going to have to make a bond to it. And have an arrow make a alkyne anion on the terminal position. So that will generate this species here. And then we're going to do what with it? We're going to do the same thing we did here with this anion and this carbon with a leaving group. It's called synthesis. It's very important. Same thing here. Lone pair, strong nucleophile. Carbon with leaving group. Backside attack, leaving group leaves, end of story. Then like backside destroyed the carbon there. There we go. Leaving group leaves. And done. That's it. There's not a lot of points on this whole deal. I'll give you a total when we're done. And then we decided that was the end of the story. And just a reminder, I think it's a dead end here. There you go. Okay, point count. See how I grade these things. 1 point for this set of arrows to do the E2, so we're at 1. 1 point for this set of arrows, 2. 1 point for this set of arrows, 3. 1 point for this intermediate, 4. Organic intermediate's got a point. Arrows, 5. There's no new intermediate. I already had that drawn. Backside attack, 6. That's not an intermediate because it was already drawn. Take the pip proton off, 7. Intermediate, 8. Arrows, 9. Somehow I'd find a way to make this worth 10 total. And that's it for that.